Kumar, and I am today excited to present my project titled The Pursuit of Fairness. It is a decentralized AI fairness auditor that ensures privacy, transparency, and accountability in machine learning systems. The pursuit of fairness is built to solve one of the biggest problems in modern AI, the presence of bias and the lack of trustworthy, verifiable audit process. My solution uses a combination of Seal Encryption, Walrus Decentralized Storage, and the Sui Blockchain to create an end-to-end fairness audit pipeline that cannot be tampered with. AI bias is not just a technical issue, it's a social problem that affects millions. Models today are used to decide who gets hired, who gets loans, who receives medical care, and even who gets stopped by law enforcement. But current fairness audits happen behind closed doors. Organizations publish fairness reports without any way to prove that the results were accurate or honest. There is no transparency, no reproducibility, and no accountability. The results in a world where AI can discriminate and no one can verify or challenge the results. And why this matters? For AI to be tested, the fairness of AI must also be tested. Regulators, users, and researchers need proof, not promises. Right now, computers can alter or hide their fairness scores. Users have no visibility in how decisions are made. Regulators cannot prove whether an audit was actually performed. We need a system where fairness audits are transparent, immutable, and cryptographically verifiable without exposing private data. The pursuit of fairness creates a decentralized auditing pipeline that works like this. The user uploads a dataset. Before it ever leaves the machine, it gets encrypted using Seal. The encrypted file is stored on Walrus Decentralized Storage. The backend computes fairness metrics from the data. The audit results are hashed and stored on the Sui blockchain. A public tamper-proof audit report is generated. The key idea is data stays private, storage is decentralized, audit results are transparent and publicly verifiable. Let me walk through the complete workflow step by step. First, the user uploads a CSV dataset through the UI. My backend immediately sends this dataset to a Node.js encryption bridge. This bridge uses a C library which generates a unique audit identity and encrypts the dataset using threshold cryptography. This ensures that the system never sees raw sensitive data. Once encrypted, the data is uploaded as a blob to Walrus and we get an immutable blob ID. With the encrypted dataset safely stored, the backend computes fairness metrics. Finally, I hash the results and store them on Sui. This provides an on-chain fingerprint proof that the audit happened and cannot be altered. Let's see a live demo of our website. We have logged in. Now let's try to select a dataset. Then we click upload and analyze. We have to wait for some time to get the audit results. In this, the first major step is Seal Encryption. The fast API backend invokes a Node.js subprocess that runs Seal client.js. Seal does three important things. It generates a unique audit identity, encrypts a dataset, and provides a backup key. What you see on screen during encryption. On the terminal, you can see the encrypted object backup key identity. This is an encrypted identity, that is the encrypted dataset. And here is a backup key, which is used for recovering the dataset. After encryption, the backend sends a encrypted blob to the Walrus. Walrus is a decentralized content addressable storage network. When the upload succeeds, Walrus returns a blob ID. The blob ID is a permanent, immutable reference to our encrypted dataset. This blob cannot be modified, edited, or deleted. Even I, as a developer, cannot tamper with it. This guarantees that the fairness audit always references the same dataset. This is the blob ID which is generated for our dataset. I can copy the blob ID and search for it on the Walrus Explorer. Here you can see the metadata, size, timestamp, and proof that the blob is stored across the Walrus network. This confirms that our encrypted dataset exists on decentralized storage independently, verifiable by anyone. Once the dataset is encrypted and stored, I run fairness metrics on the raw data, but only temporarily in memory, nothing or leak. The fairness engine computes statistical parity difference, equality opportunity difference, demographic parity, disparate impact ratio. To enhance clarity, I use an LLM via Olalama to generate expression for the metrics. For example, the statistical parity difference of minus 0.27 indicates that group A receives fewer positive outcomes than group B. This makes fairness results easy to understand even for not technical users. Here I can show you the LLM explanation which is generated for this dataset. Yeah, this is the explanation which was generated by the Olalama for our dataset. Next, I take the fairness JSON and compute a SHA-256 hash. This hash is then written to a Sui blockchain as an on-chain artifact. Because storing the full data on-chain is expensive, but storing a hash is cheap and tamper-proof. If someone modifies the fairness results later, the hash no longer matches. Here is the transaction as returned by the backend. Let me open the Sui Explorer and paste it. On the Explorer, you can see transaction succeeded, the audit hash recorded, the timestamp, the account that performed the audit. This proves that the audit occurred and nobody can alter or delete this entry. The front end now displays the Walrus blob ID, the seal identity, the encrypted object, the backup key, the fairness metrics, the Sui transaction hash. All the important evidence places are now permanently stored and verifiable. One important feature is the encrypted audit score. The fairness score is also encrypted using the seal identity, so that even the fairness risk cannot be tampered with. To summarize the security flow, Seal is used to protect data before it leaves the device, and Walrus is used to store encrypted data permanently and decentralized, and Sui is used for anchoring the fairness report hash on chain, and LLM is used to provide human-readable explanation of fairness metrics. All stages are independently verifiable, testless, and tamper-proof. We uploaded data set. It stored it on a decentralized storage, computed fairness, and anchored the results on a blockchain and verified all items through explorers. This system ensures that AI fairness audits are transparent, privacy preserving, and impossible to fake. Overview. On the front end, I built a simple interface using React and fast API templates for uploading files and viewing audit results. The backend is written in Python using fast API. It is responsible for handling the uploads, running fairness metrics, communicating with the node encryption layer, sending data to Walrus, and writing audit fingerprints to Sui. Walrus provides decentralized immutable storage for encrypted blobs. No central authority can modify the data. Sui Blockchain stores the audit metadata and hash, ensuring transparency and verifiability. And I used Seal for generating the sealed identity and encrypting the dataset. Fairness metrics. The Fairness Audit Engine computes multiple core metrics used in industry and research. Statistical parity difference checks whether positive outcomes are equally distributed across groups. Equal opportunity difference. measures if one group receives favorable outcomes at a different rate than others. Demographic parity compares overall selection rates. Disparate impact ratio. It is a regulatory standard often used in legal complaints. This metric provides a clear view of how biased or fires or fair the model's outcomes are. Let me explain why this stack is unique. Seal. It encrypts the data before it ever leaves the user machine. This ensures true privacy even when using decentralized infrastructure. Walrus provides tamper-proof decentralized storage, which means the encrypted dataset cannot be removed or edited later. Sui Blockchain anchors the fairness results publicly. Anyone can verify that the audit was performed honestly. Together, they create a system where the organization cannot fake, hide, or manipulate fairness results anymore. To conclude, the pursuit of fairness is built on a simple belief: if AI decides our future, then fairness must be provable, not optional. This project provides strong privacy through encryption, strong decentralization through Walrus, and strong transparency through Sui. It is a complete verifiable system that ensures fairness audits are trustworthy and tamper-proof. Thank you for watching and evaluating my project.